Hello. So, we're going to be talking a little bit about the history of astronomy and how we got to where we are now and all of the important figures leading up to it. Something that I want to note is that all of the astronomers that you just looked at who have done amazing things in the field of astronomy are not going to be the ones we look at here. Astronomy has been studied for as long as people have been looking up, for as long as there has been civilizations that look up and study the sky, there has been astronomy. You could track seasons by paying attention to which stars were in the sky and how many hours the sun was up for to know when is it time to plant, when is it time to harvest, more reliably than temperatures. Major events like eclipses and solstices could be tracked using structures like Stonehenge and the ziggurats at Chichen Itza. These ancient structures are actually designed in very specific ways so that when the sun and the moon line up on a solstice or during an eclipse, they light a room or they line up with the stones at Stonehenge. So these were actually astronomical tools. Entire religions formed around objects in the sky. This is the sun god in ancient Egyptian mythology. The ancient Polynesian cultures, like in Moana, were fantastic at using the stars to guide their navigation. So Polynesian cultures knew the stars. Basically, every ancient culture was studying the sky. The astronomers that we will study and the ones that you're going to be quizzed on are kind of the most well-known ones. And they're the most well-known ones because we view history through a very Eurocentric lens. We're focused on what was happening in Europe most of the time. So there are lots of astronomers from lots of cultures who have done a lot of really important things. And a lot of astronomical discoveries were made at the same time by somebody in Europe and somebody somewhere else. We just are most familiar with the European ones because of the way we view history. Another important thing to note is that, like I said, entire religions formed around objects in the sky. And when your life and everything that happens, whether or not you're allowed to plant or harvest, depends on what's happening in the sky, it's easy to see how you can believe that the things in the sky influence and determine my life and what will happen to me. So that is astrology. Astronomy is what we are going to be studying. So astrology does literally translate to the study of the stars, just like biology is the study of life and geology is the study of rocks. Astronomy means the law of the stars, but it was in like the 17th century that these really split into two different things: a scientific, rigorous study about the bodies in the sky, stars, planets, the universe, and astrology, which is a non-scientific belief that the positions of the planets influence your life. So they are separate. Astrology is not a scientific study. Astronomy is, and we are going to be studying astronomy. So as we get into the history of astronomy, there are certain assumptions that most people had based on what they could see and their own thoughts about religion and observations. And it's important to know what these assumptions were so we can see how they changed through time. So at the very beginning of the study of astronomy, people believed that Earth was at the center. This was called geocentrism. Geo means earth or rocks, centrism at the center. So Earth is where all the humans are. I'm important because I'm a human, so Earth must be the most important, so Earth is at the middle. Everything is focused on Earth. The second is that Earth doesn't move. If we were flying through the sky, I would feel it. It doesn't feel like I'm flying through the sky, so we must not be moving. So they said Earth was stationary. And lastly, they said that all orbits are circular. Circle is considered to be the most perfect shape in a lot of ancient religions and modern religions. So if the circle is the most perfect shape, Earth is perfect because it's where humans are, then the orbits have to be circular. So these were things that were explained by religion and physical observations. I don't feel like I'm moving, so I must not be. So there are a couple of important astronomers, and again, this is going to be mostly European astronomers that are important for you to know to see how we have progressed to our current beliefs about the universe. These are the ones that you're going to be quizzed on one day. So first up is Eratosthenes. He lived in 276 to 194 BCE. Even before Eratosthenes, so before 276 BCE, people believed that the Earth was a sphere. Columbus didn't prove that the Earth was round. People knew that the Earth was round even before this guy. They could tell that ships disappeared at the horizon when they went around the curve, and the particular geometry of the shadow cast by the Earth on a moon during an eclipse can only happen if the Earth is a sphere. So they already knew that. Eratosthenes calculated the circumference of the Earth with incredible accuracy. He basically stuck a pole in the ground at one city, Syene, and a same pole in another city, Alexandria. He knew the distance between these two cities, and he knew that at noon on a particular day, the sun was directly overhead. So it would cast no shadow on this pole at Syene. In Alexandria, he could measure the degree of that shadow and figure out the degree that this distance spans, and figured out using some geometry the circumference of the Earth. He found it to be 40,320 kilometers. We know it today as 40,030 kilometers. So he was incredibly close for having a couple poles sticking in the ground. Next up, around the same time, we have Aristarchus. Aristarchus was the first guy to suggest heliocentric. Remember, everyone is believing that Earth is at the center because Earth is most important. Aristarchus was the first guy to say maybe the sun is at the center. But this idea was rejected because they could not detect something called parallax. Aristarchus said it's because all the stars are too far away. Everyone else said there's no way the stars are that far away. But what's parallax? It is this apparent shift in the position of stars relative to their background. You can see parallax with other things. If you have ever held your finger out and covered one eye and pay attention to the background of your finger and then switch eyes, and it looks like your finger has jumped a little bit. So take a second to hold your finger out in front of you and swap back and forth between covering eyes, and you'll notice that it changes spots. It looks like it's jumping back and forth. If you try it with your finger really close, you can see it much better. When your finger is close, there is more of a shift. So Aristarchus said, we go around the sun. Everybody else said we should be able to see this parallax shift as we go around the sun, but we can't. We can't see it because the stars are so far away. Everybody else besides Aristarchus said there's no way the stars are that far away. They've got to be closer, and we should be able to see this jumping. So a couple hundred years later, we come across Ptolemy, who's a very well-known philosopher. Ptolemy gave the math to back the geocentric model. So Ptolemy did all of the number crunching to prove that Earth was at the center. And this was called the Ptolemaic system. And he wrote what became basically the encyclopedia of astronomy. If you needed to know anything about astronomy, you went to Ptolemy's books and you followed the Ptolemaic system. He had a bit of a problem with retrograde motion. And if you are somebody who follows astrology and says it's going to be a rough week because Mercury's in retrograde, then maybe you're familiar with retrograde motion. But it is when it seems like a planet moves backwards. So if you take a picture at midnight every night for every day for the month of the same planet, it'll look like it's moving across the sky. But sometimes it'll start to move backwards, and then it goes back to moving forwards. This time, when it's moving backwards, that's retrograde motion, when it seems like it's moving backwards. Ptolemy said, we can make this work with something called epicycles. Epicycles are essentially circles that go around circles. So here's a planet, maybe Mercury, that is still going around the Earth, but that doesn't work with retrograde motion. So actually, Mercury is going around this little circle that is looping around the big circle. To show you what it looks like, we've got Mercury still going around the Earth, but actually going around a little circle around the big circle. And that works. That explains retrograde motion. It took thousands of years for somebody to successfully challenge this. So Copernicus was the first to successfully challenge this system. Other people tried, lots of other people before Copernicus said, maybe the sun is at the center. It's a little easier. But Copernicus was successful, mostly because there was weaker political and religious control at this time. So it was easier to spread new ideas. And people were becoming more okay with the idea that Earth might be moving. So Copernicus is saying, Earth is moving, and Earth's not at the center. He's shaken a lot of worlds here. But he was successful because there was just a lot of other stuff going on at the time. People were open to new ideas. He still held on to perfectly circular orbits, though. And then this sun is at the center, Earth is just another planet going around the sun, became the Copernican revolution, where everybody now is believing that the sun is at the center. He could explain retrograde motion in a bit of a simpler way. Retrograde motion in the Copernican system happens when we lap a planet. When we are going faster than Mars here for a little while, it looks like Mars moves backwards. And that is the cause of retrograde motion, because we do know that the sun is at the center. Fast forward a little bit, we get Tycho Brahe. Tycho Brahe lived in the late 16th century, right at the beginning of the 17th century, and he is a fascinating guy. If you look really closely, or if you look at pictures of Tycho Brahe, he's actually got a bronze nose because he got in a sword fight, a duel with somebody while he was at university over the proper math to use to solve a particular problem. He and this guy got so heated about what math they should be using that they got into a sword fight, and Tycho Brahe got his nose chopped off. But he worked for the Dutch king, built this beautiful, huge observatory on an island, and just spent all day, all night, every year at his observatory staring at the sky. He measured the positions of stars and planets to the highest degree of accuracy possible. Everybody was using his data because he knew exactly where everything was. But there were still no telescopes being used to study astronomy. So he really just, with a naked eye, is staring up at the sky and had remarkably accurate measurements for the positions of all of the stars and the planets. He proposed a hybrid model that said, okay, maybe some things go around the Earth, but some things go around the stars, around the sun. That never really caught on because it was complicated and confusing. So he had this weird hybrid model, but nobody really believed it. He also had a student named Kepler, who I'm going to talk about next. And there was some drama around Kepler because Tycho Brahe was very protective of his data. He did not want anybody to claim to get the rewards, get the acknowledgement for making some discovery using his data. He wanted it to all be him. So he kept it very close to him. He died kind of mysteriously, and people thought that Kepler maybe poisoned him so that Kepler could get all of this data. Well, it was only a couple years ago they dug up Tycho's remains and did some testing and found that he actually died of a burst bladder. And so now the story goes that Tycho Brahe was having dinner with the Dutch king. Remember, the Dutch king is who paid him to do all of this observing. So you're in presence of a royalty and the guy who's signing all of your checks. Tycho Brahe thought it would be rude to get up in the middle of dinner to use the bathroom, so he held it, and he eventually died because he held his pee for too long. So Kepler was cleared. Kepler got Tycho Brahe's data and used it to develop his laws of planetary motion. So when you hear Kepler, you should think of the laws of planetary motion. This is where that third assumption gets thrown out the door. Remember, the first assumption was that the Earth was at the center of everything. Copernicus proved that wrong. The second assumption was that Earth doesn't move. If Earth is going around the sun, then it's got to be moving. So thank you again, Copernicus. The third assumption was that all the orbits are circular. Kepler took Tycho's incredible data and did the math to prove that actually all of the planets go around the sun in an ellipse, which is more like an oval than a circle. This is even exaggerated. It's very close to being a perfect circle, but it is not. It goes on a scale from 0 to 1. 0 is a perfect circle. 1 is practically a straight line. It's so flat. Earth is like a 0.002 or something like that on the scale. It is a very small difference, but it is not a perfect circle. And this solved epicycles. You don't need circles going around circles if things are moving in not perfect circles. So we don't have epicycles anymore, no perfect circles. The Earth is moving, everything goes around the sun. By the time we get to Kepler, all of that is sorted. And still, no telescopes. Until Galileo. Galileo did not invent the telescope, but he was the first person to use it to study space. And he discovered more things that destroyed any remaining notion of a perfect universe. He found sunspots, which are a magnetic feature, and they're just dark spots on the sun. He found lunar maria and craters and little oceans, kind of on the moon, not filled with water, but giant valleys and craters on the moon. And those two things proved things in space aren't perfect. The sun's got these weird dark spots. The moon has craters. They aren't perfect spheres. Things aren't perfect. He also found that Venus has phases, just like the moon does. You can see a crescent Venus and a full Venus and things like that. And he discovered the 4 largest moons of Jupiter, which are now called the Galilean moons. And those two things, the phases of Venus and the moons of Jupiter, couldn't exist if everything was going around the Earth. If everything is going around the Earth, then how could there be things that go around Jupiter? If everything's going around the Earth, then how does Venus have different shadows depending on position? Those things only work if bodies can travel around the sun. A little while later, we get Isaac Newton, we've probably heard of. He developed the law of universal gravitation. The apple falling from the tree, hitting him on the head, that's gravity. But Earth staying in orbit around the sun, that is also gravity. He came up with a new theory of light, which was essential for creating the first reflecting telescope. And we're going to talk more about telescopes next class. And he invented calculus, which was essential for further understanding the universe. Fast forward some more, we get Albert Einstein, who worked mostly in physics, but physics and astronomy are so intertwined, and his theory of relativity gave astronomers just an entirely new understanding of how the universe could work. So when you hear Einstein, think relativity. And lastly, we've got Edwin Hubble. Edwin Hubble observed that the universe is actually expanding. It is getting bigger. He established something called Hubble's law, which says that objects that are farther away from us are moving away faster. And next week, we're going to see that in practice. How are things moving away from us and how is the universe expanding? We're going to get into all of that next week. But these are the astronomers that you should be familiar with who have had a big impact on the study of astronomy and the history of astronomy. Be sure to be aware of what those 3 assumptions are about the universe and how they all fell, and these astronomers and how they contributed to the study. We're going to have a quiz on this stuff next week. Bye-bye.